Assalamualaikum. Hi guys. For this video, we are going to learn about several special case for amino acid. We are going to see what can amino acids do based on its structure. First thing first, amino acid can show optical activity, so they can exist as enantiomers. If you remember, enantiomers is isomer that have a chiral carbon, so you have a chirality center. But you have to make sure that you should know all amino acids can show the chirality center except glycine. And then when we talk about enantiomers, this isomer can rotate plane polarized light, therefore they can show optically active compound by using reflection of the mirror. So each of the alpha amino acid exists as a pair of enantiomers, so you should know how to draw the optical isomer. For example, I use alanine. Alanine is the structure of 2-aminopropanoic acid. So first thing first, I'm going to draw my structure, the general one first. Propanoic acid means 3 carbon atoms. So 3 carbon atoms. At the first carbon, you have double bond O, OH. And then at the second carbon, you have amino. So which one is our chiral carbon? It will be this carbon. So if you take a look here, we have this carbon attached to CH3, attached to NH2, attached to COOH, and another one more, it attached to hydrogen. So if I open this structure, I have hydrogen one more. So it's going to be this carbon. I'm going to label this carbon as chiral carbon. So remember, we are going to use symbol asterisk. This carbon also referring to the alpha carbon. So you can also label it as alpha carbon. So now I'm going to show you the optical isomers based on this structure of alanine. So we are going to start by showing the drawing in 3-dimensional representation. So we start with the first side first. I'm going to start with first carbon. This is our chiral carbon or alpha carbon. In this case, I'm going to show my chiral carbon. And then after that, this carbon attached to one of it adalah NH2. And then after that, it will attach to COOH. And then we have wedges and dashes. For the dashes, I'm going to put hydrogen, and for the wedges, I'm going to put CH3. And then this is our structure for the left side. I'm going to draw another one more structure at the right side by showing the mirror in the middle of it. So this is my mirror. And then we are going to show the reflection of this structure at this side. So let's start with chiral carbon first. And then I have the asterisk here. And then after that, we have NH2 and then H2. Next, we have COOH. And then we have the wedges attached to CH3. And then we have the dashes attached to hydrogen. Make sure your isomer are in tetrahedral form. So this is our optical activity based on structure alanine. Next, the most important term that you have to know in this chapter is Zwitterion. Zwitterion is one of the form for amino acid. So dia adalah satu bentuk amino acid boleh exist. So usually uncharged neutral form of amino acid ni tak wujud. Jadi untuk pastikan struktur amino acid ni wujud, amino acid itu akan undergo internal acid base reaction, di mana kita ada proton akan transfer daripada carboxyl group, this proton, dan dia akan pergi kepada amino group. So proton adalah H+, so amino ni akan terima H+, dia akan jadi NH3+. So yang tinggal adalah COO- dekat bahagian carboxyl group. So this form adalah daripada proses proton transfer, dan kita panggil formation this form adalah bentuk for Zwitterion. Zwitterion adalah dipolar ion. Maksud dipolar, ianya merujuk kepada dua-dua charge positif and negatif berada dalam satu compound. So ini adalah maksud Zwitterion. Memandangkan you already know how to detect the structure of Zwitterion, now we are going to show you how to draw the structure for Zwitterion based on several amino acids. So let's start with our ethanoic acid first. So we have here adalah glycine. So dia adalah 2 amino ethanoic acid. So we are going to show you the uncharged structure dulu, iaitu structure yang normal, tak ada charge lagi. So I'm going to draw ethanoic acid. We have 2 carbon atoms. So first carbon ada C double bond O, OH, and then the second carbon you have C, and then you ada amino group as well. So amino group ni adalah NH2 dan selebihnya dia attach kepada hydrogen. So this is our glycine. Apabila you undergo this reaction with proton transfer, so kita akan undergo this reaction menggunakan proton transfer. Saya akan gunakan reversible arrow sebab dia boleh reverse. So saya tulis proton transfer on the top of the arrow, and after that saya akan move the position of H here, move kepada amino group. So I'm going to show you another one more structure. It will be N plus H3 attached to CH2 and then attached to C double bond O and then O minus. So this is our uncharged structure and this is our Zwitterion structure. So settle for the drawing of Zwitterion for glycine. Next saya ada alanine. Alanine macam biasa, kita ada 2 amino propanoic acid. So draw dulu. Sekarang saya akan draw dalam bentuk skeletal structure. So I got propanoic acid, 3 carbons and then double bond O, OH. At the second carbon kita ada amino. So what I'm going to do, I'm going to do the proton transfer, and then we are going to have the structure attached to double bond O, O minus, dan dekat sini dia akan jadi NH3 plus. So this is our Zwitterion. This is our uncharged structure. Next we have isoleucine. So isoleucine structure yang sama kita pernah draw before this. It's pentanoic acid. So draw the pentanoic acid, 5 carbon atoms. And then after that at the first carbon you have double bond O, OH. At the third carbon you have methyl. At the second carbon you have NH2. So this is your structure. Next we are going to do the proton transfer. So draw the reversible arrow, and then I'm going to transfer hydrogen from carboxyl group to the position of amino group. So we will have our structure for Zwitterion. Yang lain kekal. So double bond O, O minus, and then NH3 plus, dan methyl group kekal sahaja. So this is our structure for Zwitterion. So I believe that's it for our special video here about activity that amino acid can show. I hope you can understand amino acid can show you the optical activity and also how you can form Zwitterion from their structure. So that's it for now. See you in the next video. Bye!